Okay, so today we're in 1.4 talking about trig functions. So what the trig functions are, they're ratios. Can everybody give me a synonym word for ratio? In math, what's the most common way you see a ratio written? You'll see lots of them already here on the board. Fractions. Ratios are most commonly fractions. They're fractions we can make out of the sides of a right triangle. So you look through the board, you can see there's a fair amount of right triangle drawings emerging. You're going to draw a lot of right triangles tonight. So before we get cooking here, let's try to remember the sides of the right triangles, what those things are called. Anybody remember any of the names on right triangles?
Side opposite of the right angle is the hypotenuse.
It is. This longest side is called the hypotenuse, or H for short. The other sides are called the legs. And until today, the legs have been sort of interchangeable for you. The legs didn't have any certain names. But starting today, what we're going to do in our experience in trig is they're going to choose for you one of these two angles to be your focus point, and then the legs are each going to get their own individual names. If I chose this angle to be my angle that I'm looking at to use as our home base, this side over here is going to be called the opposite side, O for short, because it's opposite the angle that we're looking at. And then this extra left outside is called the adjacent, or A for short. Does anybody from the English vocabulary know what the word adjacent means to?
Next to?
Next to. So right now Emily sits adjacent to Abby, and Abby sits adjacent to Emily and Raina. Just means next to. So this is the side that's next to our angle. This is the side that's opposite our angle. Instead of calling them legs, they each have their own individual names. And then there's 6 ways that we could set up fractions using those 3 letters. We could put O on top of H. We could put O on top of A. We could put A on top of O. There's 6 ways you could do that. And each of those has a name, and we're going to try to memorize these and keep these straight as best we can. So the fraction that puts the opposite over the hypotenuse is called the sine. The abbreviation for that and your calculator button for that is SIN. So if you've been looking for years at your calculator wondering what the sin button is, it's actually the sine button, and it has to do with trig and right triangles and fractions. The cosine is the name when the adjacent is on top of the hypotenuse. The tangent is when O goes on top of A. And those are like the basic, most common 3, because you have calculator buttons for those. Then there's another 3. Anybody have a perception on how can these 3 fractions kind of create those 3 in a not real complicated way? Flip. So if we flip the sine, that makes cosecant. If you flip the cosine, that makes secant. And if you flip the tan, that makes cotan. I don't know. When you flip an S, it becomes a C. When you flip a C starting word, it becomes an S starting word. Maybe that helps you. The cotangent tangent is just sort of in a family. But there's several memory tricks that people at different schools will use to keep these straight. My suggestion of what we do here is just always do sine, cosine, and tangent in that order. That's generally the order the buttons are in on your calculators, and the answers in the book are usually given in that order. Just do sine, cosine, tangent in that order. And then the saying that we use is, Oscar had a heap of apples. And that might help you keep track which letter goes with which thing. Sine, cosine, tangent in that order. Oscar had a heap of apples. There's other schools that will do stuff with like Indian chief names, and I don't even know if we can do stuff like that anymore in the days of cultural appropriation, and I'm not even sure if that's like legal, but they turned Sohchahtoa into the Indian chief Sohchahtoa, and that became like a memory trick. And some of those people will argue their trick's better than mine because they incorporated these letters as well to help you keep them all straight. I would argue, I don't think that's actually helpful because that's not actually like a historical Indian chief name. It's just a name somebody thought sounded like an Indian chief. And you could scramble most of these letters around in any order. And So Katoa is no less of a sounding like American Indian name than Ko Satoa or To Koa So, or like any scrambling of those letters you could do. So I've never even gotten into the whole like American Indian chief name memory trick that I've heard other people do, but I just feel Oscar had a heap of apples, so I think it's easier to remember, and in these days it's probably less offensive to people because who knows sometimes anymore. Question about the concept? Right triangles should remind you maybe of another thing from geometry that worked only in right triangles. Does anybody remember a thing from geometry that was right triangle specialized? The Pythagorean Theorem is still alive and well. Anybody remember anything about the Pythagorean Theorem which is alive and well? A squared plus b squared equals c squared is true, where c was representing the hypotenuse. So occasionally we did problems where we would have to get the hypotenuse, and we had a 3-step plan. Square, add, root. Sometimes we needed to get a leg. There was only one way that getting a leg had a slightly different 3-step plan. Does anybody remember what's different if you had to get a leg unknown, if it was unknown?
Subtract.
You'd subtract. You'd square, subtract, and root. So that's alive and well. I'll take a small stroll to the right. There's certain numbers that we memorized in geometry once upon a time before the pandemic hit that were triplets of numbers that went together and made those squares like work. Anybody remember a triplet?
3, 4, 5.
3, 4, 5. Because 3 squared, 9, plus 4 squared, 16, does make 5 squared, 25. That's the superstar of the triplets. Does anybody remember another triplet? Calculus can play with us too if you like. Anybody remember any other triplets of numbers from the Pythagorean Theorem?
8, 17, 15.
That is, yeah, 8, 15, 17 is a win.
5, 7, 12.
No,
That's
12 is in there.
12 is in there.
7, 12.
5, 12, 13.
5, 12, 13 is in there, yeah. 7, 24, 25 is in there. If we're going to stick with numbers under 25 and not get any rooty weird numbers, that's all you have to work on is these or some twist on these. Like if I went 6, 8, 6, 8, how could this help us create a new combo? 6, 8, 10. It's not really a new combo. I just took this combo and multiplied 2. If you saw 30, 40, it's going to be 30, 40, 50. So those are helpful to our cause. Let's do a problem and then we'll come back. Is there anything confusing?
What is the first number in the second set of triplets?
5. 5, 12, 13. So here's a partially drawn right triangle. I threw you the legs at 3 and 4. So based on the discussion we just had, you could throw me back a hypotenuse of 5. And then I'm going to pick an angle. I picked the angle A. So if this is my home base, the angle at A's corner, is this side the opposite or the adjacent?
The adjacent.
That is the adjacent. This is absolutely the hypotenuse because it's the bigger one. So this must be the opposite because it's opposite the angle that I chose. Once you figure out who O, A, and H are, then hit the fractions up. Sine, Oscar had 3 over 5. So Oscar had cosine, he
4 over 5.
tan of apples.
3 over 4.
Cosecant's the same as sine, just
5 over 3. Flip it.
flip it. Secant's the same as
5 over 4.
cosine, but flip. And cotan.
4 over 3.
Agree. Question about if I pick the A to be my angle. Which other angle could I have picked to be my angle?
C.
Disagree with C. We'll never be able to use the right angle itself. Because if we use the right angle, the opposite would be like the hypotenuse, and now we're all messed up.
B.
B. So if I wanted to focus on B instead, does anybody need those answers copied before I clear?
I'm good.
Anybody? So if I switch my point of view to B, now I'm looking here. Is this still A?
No.
No, that's,
O.
is this can't then be O, that's
A.
A. Is that still H?
Yeah.
Yeah, that's unwaveringly H. So a new voice, what would be the sine?
4 over 5.
4 over 5. A different voice, cosine.
Three over.
Agree. A different voice, tan. Agree. Cosecant, any voice?
5 over 4.
Secant,
5 over 2. 3 over 4.
and that's the basic idea of today. There's specialty problems that may get harder than that, but that's like the essential truth of what the lesson is about. Anybody troublesome, anything so forth? There are, from our geometry experiences, 2 special triangles that make a comeback into the world of trig. Does anybody remember anything about the 2 special triangles? Either how the sides went or what the angles were for, or any recollection of anything about special triangles? I'll tell you, 30 is one of the special angles. What would the other angle have to be if 30's into play with us?
60.
60. How can we figure that out even if we forgot it?
Add 30 to 90.
Yeah, because everything has to
Add to 90.
add to 180. Does anybody remember the other special number?
545.
Yeah, both a pair of 45s. True, true. Does anybody remember what happened with the sides at all in either of those triangle options? Since the 45s are the same,
Sides are the same.
which sides?
The legs.
The legs. So let me just call those 1s just to have a simple number to deal with. If these are both 1s, can anybody Pythagorean Theorem wise figure out for me what the hypotenuse would be? Root 2 is true. And maybe this will ring a bell when I nudge you toward, we used to do pictures like this where I'd say like 8, 8, and you'd come back 8 root 2. Or I'd say 12 root 2, and you'd come back 12, 12, stuff like that. We've done those a bit. Anybody remember what goes on when the 30 happened?
Isn't there's like a set number for the side opposite of 30, and then 60 is 2 times that, and then the hypotenuse is just the Pythagorean theorem thing.
That's warm. It's warm. There's something about being like half as long. Something's half as long as something, but it's not quite what he said, but he was close. Okay, the opposite 30 side is half the hypotenuse. So whatever this is, it's going to be half of that. And then we could use the Pythagorean theorem to figure this out if we forgot it. Getting the leg, so just square subtract root. Squaring this gets you.
4.
Squaring this gets you.
1.
Subtracting gets you.
5. Root 5.
Subtracting.
Oh.
3, and then we have to still root. This is the root of 3. You might remember we do stuff like, I'd say this is 6, and you play and fill the rest in. If this is 6, this would be 12. This would be 6 root 3. We did that for a while too, but that's favorite. Question about those. We just need those to be a little more active in our memory. We're going to draw some drawings with those in a little bit. Let me save these notes for a bit. I'll be back there. It is a fact of our life when we start to draw these drawings. The O and the A are going to be allowed to be negatives in the world of trig. If we're drawing ourselves pictures where we're headed like right on the x-axis is positive, if we go left, we're going to get some negative stuff. Up is always positive, so if we draw pictures that go down, we're going to get some negatives out of O's and A's. However, the H's always have to be positive. That's going to be a fact of our life because when you square stuff, it's just going to be positive. So I'm going to do book problem number 1, which involves me grabbing my book and then returning. But straight out of your homework, I'll get you started on book 1 problem. For book problem 1, I am on page 13. It says, for problems 1 to 4, find the exact value of all 6 trig functions if the terminal side passes through the point, for this one, 4, negative 3. So I'm going to draw myself an xy axis deal. Where is the point 4, negative 3?
Right 4, down 3.
Right 4, down 3. So I'll do a point there for 4, negative 3. And then we'll do what you did on the previous homework. You always on the previous homework started at the origin and drew a diagonal line somewhere. We're still doing that. The difference today is we're going to make a right triangle, but by going to the same axis as the previous homework. Which axis mattered more to us last homework? The X. We're always going to draw ourselves straight up and down kind of line to the x-axis to make ourselves a right triangle. Was this the 4 or the 3? This distance that we traveled.
4.
That was the 4. This
The 3.
is the 3. Are either of those going to be negatives?
No.
Yes.
Or the 3.
The 3. Anything that goes down or goes left is going to be negatives in our world. This is the angle we care about. The angle we care about is called the reference angle from the old homework. It always touches the x-axis. So from this angle's point of view, OA or H?
O.
O. This is
A.
A. Who is H?
5.
Agreed. And then you could write the fractions from there. Oscar had, etc. and so forth. Question about getting number 1 completed now that I got it started. Then here's a different setup to draw the same style of picture. Problems 5 to 8, they say find the 6 functions again, but they're going to tell us a quadrant and tell us what one of them is. So for number 5, they want us to draw a quadrant 2. Which quadrant is quadrant 2?
The last one on top.
Left on the top. So I'm going to just draw myself diagonally into the left top. That's quadrant 2. By way of review, that's 1, 2, 3, 4. And then from the end of that diagonal random line, we're always going to draw to the
X-axis.
x-axis. That will always make a right angle. This side, OA or H, that is H. This is the angle that I would care about. The angle that I care about will always be touching the x-axis. It's not just a drift in space somewhere. It's always touching the x-axis, which makes this be OA or H.
A.
That is A, and this is therefore
O.
O. They gave us some numbers for this. They said that the sine was going to be 4/5. So what are the letters for sine?
O over H.
O over H, Oscar had. So they say sine is 4/5, so this,
4,
4, this,
5,
5. This we can figure out, it's our good friend
3.
3, because 3, 4, 5 is the star of the law of the show. Once you do that, now you can make the fractions. If you didn't get a sine answer from your picture of 4/5, that's a really bad sign. Why would that be a really bad thing to happen? If we came back and said sine was like 3/5 or something, how would you know that was absurd? They told you already that sine is 4/5. So if you draw the whole picture and you write down a sign that's not matching what they gave you to use to draw the picture, you wrecked it. When you go to do 6, the way they wrote the negative with the 1 doesn't necessarily have to be that way. When you have fractions, whether you write the negative with the 1, or the negative with the 3, or just throw the negative in the front, that all means the same thing. But what you'll have to pay attention to on 6 is just the fact the hypotenuse can't be negative. Hypotenuse must be positive. One of those other sides must be a negative then on number 6. Question about those couple. I'm going to make a move back to the left and free up some board space. I'll go to do 9 and 10. This space looks as good as any. Okay, for 9, they want us to do all 6 answers again, but we're going to do a 60-degree angle. So we need to have a flashback to previous homework. Where was 0 degrees? To the right. Where's 90 live? Up. 180, 270, 360. That's back with us again from last lesson. They want us to find 60. So roughly there I go to find my 60. And then every picture has this in common. To make a right triangle, I have to go now to the x-axis, make a right angle. This is our reference angle that touches the x. If this were a 60 line, how far away am I from touching the x? 60. Question about picture drawing.
Is the angle 60 or is that line?
This angle right here is 60 degrees of rotation. Questioning. We know nothing about sides unless we look to this and mimic this triangle's numbering system over here. Across from the 60 should always be a root 3. So across from the 60, I want to do a root 3. Hypotenuse should always be a 2. The other leftover side is going to be a 1. And as you draw, always consider, is anything there negative? Did we go any lefts? Did we do any downs? No. So we're okay with all positive stuff. Question about the picture drawing? OA or H? O. A.
H.
Question about that? One of these answers, I'm not going to tell you which, but one of these answers temporarily would be something like 2 over root 3. That would be a fraction we would make. And the math community would criticize that. Why would they criticize an answer like 2 over root 3?
Roots can't be on the bottom.
Roots aren't allowed to be on the bottom. Do you remember how to fix that?
Multiply it by a root. Multiply both by the root 3.
Yeah, multiply the bottom by root 3, so it's now
3.
normal 3. Multiply the top by
Root 3.
root 3, and it's now,
2 root 3.
and that's a better answer. There are also going to be some questions in the homework where you might have like a 2 and a 4. Follow the 3-step plan. Which root will that be, dealing with a 2 and a 4 on our legs? Oh, you went too far.
Root 20.
Root 20 would be the first thing that would appear to our mind. Squaring gets 16 and 4 to add to get 20. root 20, better known as 2 root 5. Does anybody need a re-reminder of how to make that step on the, okay, so think about that 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, those kinds of numbers. Find any of these that can divide into that. 4 goes into this 5 times. So 5 is stuck. 4 we chose because it's special, it's a perfect square that can root into 2. So if I gave you something like 75, 25 is your helper. 25 is special because it can become 5. So there's a normal 5 going to come out. And 25 into 75, it went 3 times. Okay? Anybody else need a little summary on that move? You're better to fix that as soon as you find it rather than try to fix it 6 times once it's scattered to 6 different answers. So as soon as you notice one of those, you're better to fix it. The whole root on the bottom thing, I wouldn't fix that until the end when you're seemingly completely done, because if you have a root on the bottom and you fix it, sometimes you make other answers by flipping them. So if you have an imperfect answer, fix it. Make the root not be on the bottom, but be on the top instead, and then you flip it. You gotta like do it again. So I wouldn't worry about any roots on any bottoms until you're completely done. Because if this was a base answer, and it needs fixed later, when we flip it, it like self-fixed itself. So roots on the bottom, don't worry about till you're seemingly done, but the simplifying roots, don't let that be like a weed all throughout your problem. Let me do 10. Same kind of scheme on 10. They say 135. So again, that's 0. That's 90. That's 180. Roughly, that's going to be 135. And then we always go to x-axis. How far away is 135 from 180? 45, which makes this other one 45. And what we're trying to do is recreate this triangle, just kind of like swiveled into position. The legs are both 1s. The hypotenuse, root 2. And before you get too excited and start writing down fractions, you always need to think about whether anything is negative. Is this one?
Yeah.
Yes, because it went left. Is that one?
No.
No, because it went up. And now you'd make the fraction. Question about 1, 5, 9, 10, or the idea so far. Okay, things get easier at 15. On 15, they no longer are asking you to do all 6. They're only asking you to do 1. And they're saying you might be able to do this quickly from memory or from visualizing things, but that's probably not true yet, but will be true at some point in our life together. That after you've kind of re-mimicked these triangles enough times, you start to be able to like be okay with them without actually drawing them. But if you need to still draw them, feel free to draw them. In this section from 15 to 26, they'll pop in a couple that I'll call special cases. So if I gave you an angle of 0, where would I draw to draw an angle of 0?
What's the effect?
So something like this. And then I'm supposed to make a triangle out of this by drawing from the tip to the x-axis. But I can't really draw from here to the x-axis because I'm already on the x-axis. So 0 merits a special discussion because you can't make a triangle out of it. So I'll think creatively this way. I can't really draw 0 to get a triangle made, but I could probably draw 1, right? Like a 1 degree, I could draw that. So if we draw a 1 and use our imagination, that I like zoomed in a super magnifying glass, and that's actually 1 degree, and it's a lot tighter to this than it truly is. this would be the angle I cared about. Is this O, A, or H?
O,
That is O. This is
H,
H, this is
A.
A. If I crunch this down, angle, but a 0 degree angle, what's something that would happen among O, A, or H, relatively speaking, if we tried to not make this be a 1 degree angle anymore, but truly be a 0? What would happen?
It'll be the same.
What would be the same?
A,
Not all of them. If I scrunched this, 2 of them would be the same.
A,
A and H. A would end up on top of H. What would O be?
nothing.
This is still a number though. 0. O would be 0. A and H would be equal. So it's worth just writing these in the notes for now, but eventually we'll memorize some of this, but today's not the day to scare you with memorizing things. If the O is basically 0, and the A and H are basically a match, how much would sine be? If O is basically 0, and A and H are just whatever,
0.
sine would be 0. Cosine? What would cosine be if A and H are basically the same?
1.
1. Because A over H, stuff over itself, would be 1. Tan? What would tan basically be?
0.
0. What do you think would happen if you flipped a 0?
Impossible.
It is impossible. What happens if you flip a 1? It's still 1. And flipping a 0 is impossible. If you didn't understand that, it's okay. Just make a note out of it. If zeros are used in the homework, just steal the answer I just did for you. If they did 180 instead of 0, would you have the same basic predicament? Yes, because 180 would land here. If they ask you to do 180, it's the same list. But since 180 is tending toward the left instead of the right, 180's list would be negative if possible. You can't have negative 0 or negative impossible, but you could have negative 1. Let's do 90. If I wanted to draw 90, where would I go? Straight up. And then the instruction of the day is, I've told you always draw to the,
X-axis.
which is straight back down. Is that a triangle? No. So 90 itself is sort of deceptive because we can't draw a triangle. So think about a similar-ish kind of number that is drawable. Who's close to 90 and drawable?
89.
89 works for me. So if I drew an 89 degree angle, I could return to the x-axis in a super magnified sort of way. This would be my angle, OA or H?
O.
O.
H.
H, so that must be A. This time we're imagining crushing it this way. So if we crushed it that way, who is 0? A. O and H would basically be the same. So sine this time is 1. Cosine
0.
is 0. Tan
Yeah.
tan?
1.
Disagree?
0.
Disagree.
Possible.
Impossible. Because we'd be putting O over A, 0 on the bottom. We're never allowed to do that. Flipping 1 makes
1.
1. Flipping 0,
Impossible.
possible. So flipping impossible
Possible. 0.
must be 0. If I lost you with Y, don't worry about it. As long as you have the note, you'll survive it. Since 90 shares an axis with 270, 270 is the same list. put negative also, when available. Not negative 0 is not negative impossible. Question about any of that? So let me do two more. So 15, they want just the sine of 180. All you're going to have to do for that one is use this note, right? 180 is in the note. Just sine takes us here. Make it negative if available. You can't. 15, they're just after the 0. That's all they want. 16, they want you to go after sine 225. I might suggest you go picture style still on this, because 225 wasn't in that set of notes. Not everything in this grouping is in that set of notes, but somewhat. Where's 225? Quadrant 1, 2, 3. It is in 3. This was 180. So if this is 225, this is
45.
45. We can draw as we wish to the
X-axis.
x-axis. 45, ring a bell to this structure with legs of 1s and a hypotenuse of root 2. This is the angle we care about, making this be,
O. N. B.
before we get too excited and write down an answer, is anything
Negative.
negative? Is? Who?
O.
Agree?
A.
Agree. Because it went left and it went down. For number 16, all they want is sine. So what is the sine at first glance?
Negative 1 over root 2.
Agree. Better answer than that once you'd fix it?
Negative 1 root 2 over 2.
Agree. And you don't even have to write the 1, it wouldn't hurt if you did. That's what you're doing. You're going to 26, doing that. Will be the same section tomorrow, keep on going, but I'll have a more streamlined way to do it. That involves you not having to write these triangles down like 1,000 times every day for the rest of your life. Anything? That's it.